Welcome to Using GeoGebra Part 3. I will give another example now from triangle geometry that is about Thales theorem. Thales theorem, recall that it says if you have a semicircle about a diameter, then every angle up here is a right angle. So always 90 degrees, whatever point C I pick on that semicircle. So this is implemented as follows. I need the two basic points, and already the point A is defined like intersection of the two axes, because I just put my mouse there when I put on the point A. Point B, I put certain distance aside, and then I get Strecke, AB, that is the German word for a distance, for a straight line of a certain distance, certain length. And I named this variable accordingly. It is helpful if you use names for your variables that are immediately detectable. It is not necessary you can put in every name that you want. And if you do not put in a name, then GeoGebra will give you one automatically. But for somewhat more elaborate diagrams, it's always helpful to name all variables yourself and to name them in a way that you recall their meaning immediately. So if I do that, I get Thales theorem, and Thales theorem with different positions of the point C, and always, as you see, there is a right angle up there. Okay, further, a circle may be defined by a center and its radius, by a center and 1 point on the circle, or by 3 points. Further, you may define sections or semicircles and so on. A lot of options. Yeah. Good. Another example for that is these two circles. I define one circle and I find a circle around the other one. Then I need different definitions. For the first one, I have just a circle of a certain diameter. Okay, and then I have another, about this point, I have another circle of another diameter. Yeah, I can do that. And I can change, afterwards I can change the points and everything moves together. Yeah. Another example of from circle geometry is about the circumference of a triangle. The circumference of a triangle is the center of the circumference is the common intersection of the three middle sections of the triangle. So if you cut every side in half and make a perpendicular line on the side, all these three perpendicular lines, they intersect in 1 point, and that is the center of the circumference. That's a basic geometric theorem about that. And in this example, you can the best way to work with this is actually to write it down and to write down the commands yourself and try it out in GeoGebra. You get that yourself. There is a command for that. You can use an abbreviation, but I recommend that you use this as an example and try it out. Okay, I will give another example. This time something numeric. And it's something simple but interesting numeric. It's a method to determine square roots. It's called Heron's method or the Babylonian method. Very old, so the Babylonian already knew it. The idea is as follows. You begin with a number a, and you want to have the square root of this number a. Okay. First thing is we define an area, capital A equals small a times 1, of course. Yeah. If I make times 1, then both numbers as numbers are the same. Physically speaking, they have different dimensions, but that is the same number. Okay, and now I do something iteratively that brings me in the direction of the square root, and that is this side A is always iteratively defined in U as the middle of both sides. So the average of both sides is the new side A, and the new side B I can then calculate from the area always. And as this is the average, it will be closer to the square. So if I repeat this process, it is very clear that my rectangle step by step is turned more and more into a square, and thereby I am getting the square root as the side of the rectangle, because this is getting more and more to a square. Yeah, this is written in formulas here. Iteratively, we take the average of both sides as a new side A, and a new side B is calculated from the area. So new A is old A plus old B divided by 2, and the new B is the area A divided by the new A. So the area remains unchanged, but the form becomes more and more quadratic, so both sides approximate the square root step by step. A numeric example here with the square root of 2. At first I just gave the command a equals 2. I typed this into the computer. If you do that, you type in a equals 2, he immediately prepares a slider for you that helps you later on. If you have your calculation, you can change the number here just using the mouse and change the slider. I did one little thing also. I changed the boundaries of the slider, that from something minus, which I don't need, to 0 and up to 10 here. Same with B, but with B actually I don't need the slider, because B equals 1 in the beginning and the rest of the B's is calculated. So that doesn't matter much. But then the area is A times B. The new A, A1, is A plus B divided by 2. That gives 1.5 now at first. The new B, new side B, then is the area divided by A1, and that is about 1.33. And so on. I did this in 3 steps, and as you can see, in 3 steps, I'm already at quite some, I have quite some accuracy attained in there. Okay, so I told you about the sliders. You get them offered from GeoGebra for free. You can use them or ignore as needed. Another interesting thing is here he does a calculation in fractions, but sometimes I need a numeric value to compare values. Then I can use this blue button here, or I need the value as fractions to compare if the algorithm works correctly. I can do the calculation in fractions and compare. Either one of them, you can just change this blue button, and he will toggle between fractions and numeric values. Another example now about solving equations. I define the equation in that I just type it in and I give it a name, like GL1 double point and then 3x minus 7 equals 0. I defined in that way. I defined it an equation. If in the next line I say solve GL1, That is the German word löse, is the German word for solve. He just gives me the x as a fraction. Yeah. If I do the same with a quadratic equation, I get the two solutions here. Yeah. So he has quite some symbolic algebra included that you can use. Not everything, but quite something. You can work with that. Next example, differentiation and showing the result of differentiation. I have a function f of x equals e to the x. I put, with a mouse, I put a point on my curve, on my object, and then I can tell him I want the tangent in this point. I want the tangent to the curve in this point. He calculates the equation of the tangent line, and afterwards I can put in the inclination, and he gives me the inclination. So very straightforward to make a demonstration about differentiation and tangent lines. So you enter the function just in the command section, f of x equals e to the x. Afterwards you get the curve. He writes down the curve. You take your mouse, you make a point on object is this, Punkt auf Objekt, point on object, and click to the curve and click to some point. To set a point on the object, you can later on change the position of the point with this arrow sign, with the moving, yeah, with this arrow sign. If this is done, you go to the menu for lines and choose a tangent line, and you again you see this black down here. You see this black explanation. He explains you how to use this command. He does this with every single command here, so that helps that you don't need to remember how to parameterize these different commands. Okay, and then the next one, this Steigung, German word Steigung means inclination. He gives you the inclination of this tangent. And then I have everything together for my demonstration. Yeah. And I can subsequently change the point, push it somewhere else. The tangent follows along, and the triangle showing the inclination also follows along. You can do symbolic calculation of an integral. That's another example here. Very simple. Integral of 1 over x. I had him integrate. And he gives the correct answer, even together with the integration constant. So he put in the C1, the integration constant, and by default he set it to 0. You can change this, of course. Yeah, you can change this this setting, and then he will change the function. He will not write down ln of x anymore, ln of absolute value of x, but plus C1, plus this number. Yeah, in that case. Good. How do I enter that? I go to the command section. I just start entering int, and then he knows I want to put in some integral. And he gives me here in the submenu, he gives me the different options, how I can choose different options and parameterize them. And that's for now. And the slider gives the integration context, and you can continue from there. Yeah. Okay, that is about the short overview on how to use GeoGebra.